Hello there. This video is going to be about protein as represented in Minecraft. So I'm going to go ahead and go over here and give a quick synopsis of what all of these blocks mean, and then go through each one of the four structures, starting at primary, then going to secondary, then tertiary, then quaternary. Okay, so all of these are amino acids, and these are the specific types. So all of the yellow sponge blocks are hydrophilic acids, or amino acids that like to be near water. Philic, as in like, and hydro as in water. So yeah, they're going to like water, which will be important when we get up to tertiary. Also important in tertiary is cysteine, or cysteine, I believe, which is these slime blocks. And slime blocks love to be near each other. They want to be next to each other. So when we get to tertiary, they're going to want to get next to each other, and we'll see what effect that has later. Hydrophobic acids are the opposite of hydrophilic, and they want to be as far away from the water as possible. Finally, all of these gray bedrock blocks are miscellaneous amino acids. So there's 20 amino acids in all, but instead of going on all of them, these are the three we want to focus on, so the rest are just grayed out. They could be any in any order. So, let's go ahead and look at the first one, which is the primary structure. So this is pretty much just a straight line, a polypeptide chain of amino acids combined with peptide bonds, which are these little fences. As you can see, I made 20 blocks, which is a nice number, and we'll have to remember that up through the next couple structures. So they each just have a single bond with each other and just kind of make a long chain. So then we go up to the secondary structure, which looks pretty much the same, but with just a couple of differences. The secondary structure, the only real difference between it and the primary structure is that secondary structure has A helixes or alpha helixes or beta pleated sheets. So this is just a change in the peptide bonds so that the chain looks a tad bit different. No huge changes yet, but it does look different enough to be its own structure. Again, this is the secondary structure, the second structure in the thing. So I tried to represent a alpha helix with these fences here. As you can see, they kind of crisscross with each other, and that happens again over here. So yeah, again, not much of a difference. Finally, we get up here, and you can see suddenly a whole lot changed. So the tertiary structure is where folding actually comes into play. So, and where all those amino acids we described before come into play. So, these hydrophilic amino acids want to be towards the outside of the molecule, of the protein molecule, seeing as they want to be near water, and water is going to be on the outside, not the inside. So they're going to start going out. The hydrophobic amino acids, on the other hand, oh god. Oh no. Up, back up. Okay, the amino acids that are hydrophobic are going to want to go to the center, because that's where the water is not. They'll be surrounded by all these other amino acids, so they don't have to get wet. Finally, down here, we have the cysteine amino acids, which at the beginning were far apart, but as soon as it started folding, they went wham together and got as close to each other as they could, folding up the whole molecule. So as all of these shift around to form this tertiary structure, the third structure in our little timeline thing, that's pretty much the entirety of a single chain. So it just has this big bundle. Now, when you take one of these bundles and put them with another one of the bundles, you have a quaternary structure. So these white ones are pretty much just bedrock from those, but from a different polypeptide chain. So all of that happened, but with a different chain, and then we just clump these two together. So you can see we have more of these hydrophobic and hydrophilic acids. We have more cysteine, which is trying to combine with each other all over the place. And obviously we have a bunch of other miscellaneous amino acids. So now it's gotten bigger, and they're just all joined together in one huge clump. And yeah, that's pretty much the long and short of it. We start down here at the primary structure, which is just pretty much a straight line of peptide bonds, creating a polypeptide chain of amino acids. Next we go up to the secondary structure, which is just either a helix, which is represented here, or a B-pleated sheet, which is kind of like a zigzag. This is a crisscross, so that's more of a zigzag. And this is a, well, not like, it's not really crisscross. I guess it's crisscross. It's hard to do it. I'm limited by my medium. Anyway, next we go up here. We have our tertiary structure, which is just all of them folded together with the hydrophobic on the inside, hydrophilic on the outside, and the cysteine womping together. And finally, when you have a bunch of those and you put them together, you finally get your full-out protein molecule, which makes up all of us, like hemoglobin or any other kind of protein. So yep, I hope this was helpful. I hope it gave you a visual or maybe gave you some terms you might need. And yeah, I hope you have or had a wonderful day. Bye.